Proof triangles similar by SSS and SAS. This is lesson 6.5. Now, before we start, let's review the other way to prove triangles similar, and that was by AAA, angle, angle, angle. So let's draw one of these. Here is a right triangle, and I'm going to announce that it's right by drawing the little box in here. Here's another right triangle. And then I need to go ahead and put in an angle. So let's suppose this angle is 30. And this angle is 30. That would make this angle 60. And this angle 60. Now, because of all three angles are the same, we do have AAA. And that means that these triangles aren't congruent because the side lengths are the same, but they are similar, which means that the sides are in proportion to each other. So if one side is, let's say, 4, and this side is 6, then all we need is one other side, and we can get the rest of the sides. So let's say that this side is 6. Now, to solve this, we need to pick an x right here. We can say that 4 is to 6 as 6 is to x. Now remember, there are other ways to write true statements. I could have said 6 is to x as 4 is to 6, or flip it over and say 6 over 4 is x over 6, but we're going to get the same thing that we did before. So another trick is, you don't have to do it, but it's easier if this ratio can be reduced to go ahead and do it. Okay, to solve this, we have an equal sign, so that means I can cross multiply. I can multiply the two numbers across from each other and then divide by the third number. So 6 times 3 is 18, and divide by 2 is 9. So x equals 9, which would make sense. Now, because these are right triangles, if I wanted to, I could go ahead and solve for the third side and have all three sides of the triangle. So that was proving triangles similar by AAA. Now, let's go ahead and go to SSS. Okay, these are three triangles. Let's see if they're similar to each other. For the SSS similarity theorem to work, all three sides need to be in proportion to the other sides. So, one of the hardest things about doing this is to make sure that you have the right sides, the correct sides being similar to the other correct sides. So let's look for the smallest side in each triangle. Remember, the smallest side is across from the smallest angle if they were drawn in proportion or right. So we just need to look for the smallest side. So let's look for these two triangles first. So 8, which is the smallest side over here. Now I need to find the smallest side over here is 4. So 8 over 4, and we're going to see if that equals in proportion to the other sides in these triangles. So let's go for the medium side, which is 9, over the medium side here, which is 6, and then the smallest, or the longest side is 12, and the longest side here is 8. Okay, we can do this one of either ways. We could cross multiply and see if they're the same, or we could reduce everything and see if they're the same. So 8 over 4 reduces to 2 over 1, right? Does 9 over 12 reduce to 2 over 1? No. And 12 over 8 doesn't reduce to 2 over 1. So the first two triangles are not similar. So if we had an unknown side length, we couldn't solve for that with what we have. So let's look at this third triangle. Which triangles do we think that they could be compared to? Let's go for this first one and the last one. Okay, so let's write the similarity statements. Let's find the shortest side again. So 8 over 18, does it equal 9 over 16? And does that equal 12 over 24? Well, no. That doesn't work either. But I made a mistake. What's my mistake? Well, remember here, this is the shortest side, the 8. What's the shortest side over here? It's not the 18, is it? It's the 16. So I should have put my 16 here. And here's the medium side, the 9. Where's the medium side over here? Well, that was the 18. Okay, that looks better. Like I said, this is the easiest thing to mix up on these. So 8 over 16 and 9 over 18 and 12 over 24, yes, they are all equal, and they reduce to the fraction 1/2. So I can say that the first triangle and the last triangle are similar, and that is SSS, where all the angles are the same, and you don't have to prove that because you're going to prove that all the sides are in proportion. Now, what can we do with that information? Well, if I needed to prove like angle H equals angle B, I could do that now because corresponding parts of similar triangles or corresponding angles of similar triangles are congruent. And a lot of geometry people reduce that to corresponding angles of similar triangles are congruent cast. Here's the last way to prove that triangles are similar. We can do side, angle, side. Now, don't get this confused with congruent because we had the side, angle, side, and congruent. And for side, angle, side for congruent, we had to make sure that the sides were equal and then the angles were equal. For similar, what we need to prove is that the sides are proportional. And then the included angle is equal. Okay, so let's look at one of those. If we have two triangles Let's see. Like this. Now I could have drawn them better, of course. And I said that this side is 9, and this side is 18. This side is 12, and that side is 24. Can we say that these are similar to each other? Well, we could write the proportionality statement and see. So, 9 is to 12 as 18 is to 24. And are they the same? Sure, because if I reduce these down, I get 3/4 for both of them. So, these are proportional sides. Now I need an included angle. So what is the angle between the two sides that we have on each? It's this angle and this angle. So right away we know that those two angles are equal. And how do we know that? Do you remember? Those are called vertical angles. And vertical angles are always congruent. So, we have proved these two triangles are similar now because of SAS. The sides are in proportion, the included angle is equal. And then how could we use that information? Well, we could say that these angles now are equal to these angles. Okay. So to recap, the three ways to prove that a triangle is similar to another triangle is by using AAA, which means all the angles are equal to each other, by using SSS, which means that all the sides are in proportion to each other, or by using SAS, which means two sides are proportional and their included angle is equal.